Part 2. So, stream coming through. Oh, sorry. Okay, coming through. So we're live, creating the broadcast. We are live, I think now. Yes, we'll probably do 30 minutes, 30, 40 minutes, and we'll continue with our posties. So again, we are in the middle of using these streams as well to test the system, to really test how well it works across the different multiple use cases, right? Yesterday I did these, which I wanted to briefly touch upon because I think it's an important distinction for people to understand what openLesson is. So I did this image here, which essentially is basically trying to explain what openLesson is in comparison to other applications that do things like generating content for you. And I'm not so sure where the Eureka team is going to go for, because Eureka Labs, essentially the way they talk about these is like they basically seem to be and this is Carpathia's startup, right, or company, and they've been working since like July 2024. So I don't know really what they'll come up with, but essentially they have this course, and it seems like they're more focusing on the crafting of the content itself, and then sort of an LLM that is specifically trained on that content, right? That is specifically trained on that content and is trained on adapting the way that you navigate the content based on your needs, or something like these, right? When they talk about like because they say, by then you should have, no, it says that here that yes, that you will be building these AI course, which is basically through training of your own AI, very similar to a smaller version of the AI teaching assistant itself. I almost feel like they're going to actually just build a teaching assistant. They're going to build like an LLM, like a chat bot interface where you can ask, you can ask it to help you navigate the content or something like this, right? And so that's one thing. There's a bunch of things going on in the educational space these days. So there's also a few companies popping up around this concept of like tailoring content and whatnot. But those would all go down this adaptive learning side of things here. And what we are building is we're building these. And sorry, it might get a little loud in a second because of the baby. But yeah. So, but again, openLesson is this side. Is a tutoring harness, right? So essentially, we do not really care. The tool is not about curating content for you, because I deeply believe that that is not where the optimization is. You know what I mean? There is the way you can like, yes, in a way there is, in the space of all the possible shapes and forms of content that you're trying to learn, there is one form that is for some reason more optimal for you to understand. Okay, but that is just the understanding piece, right? So where you have much more space to optimize is on the loop itself, right? How are you thinking about stuff? Are you going through the right questions? Are you digging down the right path? How are you iterating? What is the next thing that you're going to talk about if you just talked about these? Stuff like these. And this is what I call the tutoring, like the harness, right? So just having said that, let's move on. Let's move on to the actual thing. So let's go through. We'll go to the dashboard. We'll actually log in, and what I will do is I've changed a few things you will notice, but I think that the system should be much more robust already by now. So what I'm going to do is we are going to go to the PCB design plan. We now have these marked as completed, the introduction to PCB. And now essentially we have the option to go through the electronic components and schematics, PCB design software overview, circuit schematic, capture. So I'm feeling like capturing schematics digitally is crucial for translating ideas into manufacturable designs. Routing techniques, effective layout and routing ensure signal integrity and manufacturability of the board. I'm between these routing thing and also the design software piece. Although I think I'm gonna go because electronic components and semantics is learn about the components and schematic diagrams enables accurate representation of the circuit functionality. Um, I'm not sure this is going to be useful. I don't know if I'm going to ask it to redo the plan a little bit. But what I'll do today is I'm curious about these. I'm curious about the routing techniques. So let's just jump to this. Let's just jump to this one. So it's going to start preparing, and I'm gonna do the EEG as well. So I'm gonna do the EEG stuff, E data, and we'll probably do 30 minutes. I'm gonna time it to 30 minutes. Then I might connect later. No, I will connect later for some for more stuff. But let's do these. So okay, we'll get started. Right, what do we have? Okay, so what is crosstalk in PCB designs, and can you recall a basic example from your previous knowledge and how component placement might influence crosstalk? Let's talk. So we'll start diving into crosstalk first. Then we have drawing a simple diagram to minimize crosstalk. Then we have factors like signal proximity. Okay, so it's going to be. I don't think we can go through the session by far, but let's dive into crosstalk. I will say that I'm thinking about connecting. Like I almost feel like it's fine. Yeah, good the way it's connect. I think I need to enable Bluetooth enabled. Yeah, here. So let's connect it. Waiting for a signal. Perfect. All right. So, what is crosstalk in PCB design, and can you recall a basic example from your previous knowledge of how component placement might influence it? I don't know, but again, what crosstalk probably means is that signal that is going through a path somehow jumps into another path where it shouldn't actually jump. This is kind of my what I would deduct by um, just by trying to understand the semantics because it's crosstalk and I somehow that rings a bell from some concepts in circuit design back when I was at university doing computer science and stuff like these. So it might be these. Wait, I think we have a problem. Now you'll probably hear my voice better, and also the recording is going to be cleaner. Sorry, I had the headset connected. But I think that is what it is. So let me just draw a few things, right? So it's just as simple as like you have your board in here. That's the way that I'm thinking about it. And then let's imagine you have a path that is going from one component like the to another component. I don't know. Then um, and then you have another piece here, another component, and then there is another cable, or not cable. There's another something that goes like that, and maybe that's something like the. And because this section is very close to each other, I have the feeling that what's happening here um, is these. What is cross? Is I think that's what it is, but I'm not 100% sure. So I will ask the teaching crosstalking people. I think that is a good example though. Although it probably can happen in between
components as well, and maybe it can happen. Maybe it happens in between layers, right? Well, for sure. I mean, if you have multiple conductive layers, that's probably also going to happen. So this means, although maybe it's then minimized, because I don't know what would be the purpose of having multi layers then if you can't just you know lay out paths close to each other vertically, then you might as well just squeeze everything in one design. Although maybe the effects are in a way minimized. That is my thinking. So, but let's just ask, so what is crosstalk PCB? Okay, so we got another question. What specific component placement could cause crosstalk between adjacent traces? What specific component placement? Okay, that's interesting. Why a component placement? Why why a specific component placement would cause crosstalk? Adjacent traces. Okay, so this question is implying that because this question is implying that because we have the layout like these, they don't have to necessarily actually generate like have crosstalk. Um, maybe I'm wrong from from the very beginning, right? So because let's just ask crosstalk in PCB design. Maybe missing like a specific nuance. Crosstalk in PCB design refers to unwanted signal interference. Okay. Between adjacent traces or components. Okay, so also components. Think about it, how signals on one trace can couple to another electromagnetically or capacity. Okay, there's definitely more depth to this. Electromagnetically or capacity affecting performance. What might cause crosstalk in high-speed circuits, and how could you mitigate? Um, isn't just simple proximity is what comes to mind. But maybe it's more than these. Maybe it's like how much labor charge, or how much like electricity. You know what I mean? Like maybe you can limit that. And so if you control the flow a little more, then you're minimizing the chances of that. You know what I mean? With capacitor or something like this. I know. Very new to all this. So we're definitely gonna have to read a bit about these. Proximity is indeed primary cause. Yes, too close can lead to the. But what about signal speed? Is it signal speed, or is it uh? So is it because maybe so so the speed leads to maybe changes in the electromagnetic field, right? Because we know, so essentially electrical current has an electrical has a magnetic field that is generating, right? So it's probably, so that's the signal speed probably leads to electromagnetic field changes, maybe, and then the interference happens electromagnetic. But interference happens electromagnetic. Uh, why is this even bad? If all we care, if all we care is, um, all that we care is electricity, right? We got another question here that says, what if I place a clock signal near audio line? Would that cause electromagnetic fields from fast changing signals can induce unwanted voltages or currents in nearby traces? Okay, yes, recording the intended electrical signals. That was my original kind of concept. This leads to errors like noise timing issues or data corruption. Noise, because you're adding signal, timing issues, because yes, you might speed up certain signals, I guess, and data corruption. Because maybe if those paths lead to some memory component, bad because it compromises signal integrity, even though we ultimately care about electrical behavior. How might this affect digital result? Wait, I'm not so sure this question. Go through the what is crosstalk in design, and can you recall a basic example? I mean, I think the basic example is what I've been talking about. We're done with it. This crosstalk in business as a can you recall basic? Uh, I mean, let's an example is complicated. Actually, that's a good point. I mean, let's think through this first. An example, what it would be, what would an example be? To be honest, I have no idea. I have no idea what an example would. Like, I understand the concept, but the example would be what? Would the example be related to maybe like, it's an electrical component that is plugged into the wall socket, and there's like, I don't know why would a so why would you have a change? What will cause a change in, and maybe because I'm coming too much from theory land, right? Signals, uh, trying to look for adjacent trace. Um, coding, yeah. Because what I'm trying to what would cause a circuit suddenly suffer from some electrical uh change or something like this? You know what I mean? Like, I'm assuming if the design is good. I mean, again, what specific component placement could cause crosstalk between adjacent traces? This question actually has me a bit wondering. Sudden changes in electrical speed, like single switching rates in a circuit, could stem from factors like voltage fluctuations, temperature variations. Crap, yeah, temperature variations, component aging, external interference. So there's so much I don't know. There's so much I don't know about any of these. That's gonna be, it's definitely fun to like dig into these. Um, it's a total opposition to alternating current flow in a circuit, combining resistance, active resistance, capacitive. Okay, bro, that's definitely another rabbit hole. In PCBs, it's key for matching signal paths to prevent reflection in integrity. Whoa, reflection. Uh, Bro, this is so deep actually. Okay, cool. So, um, let's take some notes, because we have here things that could cause crosstalk. It's like impedance, bullet points with most common uh that um could cause what? That could cause crosstalk. And then I think I just have to go and dig through those. These are just basically things But let's try to get to the fundamental of the crosstalk, because I get the problem. I get why this is problematic. But what is the first principle behind this? Like, what's the so what is the factor that will cause this crosstalk risk freeze? Are these things basically so, I mean, close proximity of signal traces is fine. It's fine. Let's just sometimes you must do that because you don't have more space to design the PC. Enabling capacitive coupling. Um, okay, the coupling it's the actual crosstalk. High signal frequency. High signal frequency. Long parallel trace run. Okay, but that's a specific design pattern. Long parallel trace runs. Absence of ground planes or improper ground. Impedance mismatches leading to reflections and noise, but I don't know. Well, the easiest one to mitigate is just put the traces like close to each other. But what specific component placement cause crosstalk between adjacent traces? Component placement. So is component placement a factor at all? Maybe it's a specific component, like maybe this is related to like a capacitor or like the storage, or even you know what I mean, like where this question is going to. Yes, component placement is a key factor in crosstalk. Poor placement can force longer traces or closer routing of sensitive using coupling. You might how might grouping components help me? Okay, so actually this is related to poor placement of okay, so the component specifically it's talking about the component placement forcing longer traces. Yes, okay, fine, but that's like this to me is like is an effect. Well, it's just the design. Like I'm not drawing the traces because I just like the way they look like, right? Closer routing. Am I grouping noisy and sensitive components to help minimize? Well, I guess noisy components could be. I guess the thing is noisy components could be placed together so that the noise is contained in one side. Uh, Maybe grouped together so noise contained or easier to isolate. Noise, I guess, because I guess noises means probably some components kind of like a I don't know leak or something. I don't know what the right wording would. Um, but I think that's the way that putting noisy components together could help contain interference with localized area, making it easier to shield or isolate the section. However, it might also contain noise, amplifying local cap. Um, I did notice that I have the feel chat keeps always almost like asking, but I actually I don't dislike this. It's okay. So what specific component placement? Um, Diagnose. A work perspective. Uh, so what specific component placement would cause crosstalk between adjacent traces? Um, well, I think essentially that's what it is, right? What component? I mean, maybe what? Maybe yeah, specific components are more susceptible to that. They're more specific components which are more prone um, crosstalk issues, like maybe I don't know. I'm. This is definitely like I'm actually getting. I think one of the reasons just I'm testing this, right? So I'm just looking at. Okay, something. Okay, cool. So but I'll just move on manually. I think that I let me see. I'll just be back to the um. All right. The updates don't seem to work, but it's just routing issue. That's why the question. Anyway, certain components are more susceptible to crosstalk due to their sensitivity or noise generation. High-speed digital IC components, analog devices such as am sent. But I think I'm good with these. I'm good with these. I think I'm good with what is crosstalk in PCB design, and can you recall a basic example? I think we're good with the um yeah, I think we're good with crosstalk. I mean, we talked about like the different things, so there's just definitely a lot to dive into, right? But I would then specifically generate sessions for that. We're good with these. So for now, I'm gonna mark it as complete. I maybe will come back to these. Um and yes, and now draw a simple diagram of PCB with components placed to minimize crosstalk labeling. Uh, okay. I'm gonna pause here. So where should I position the power supply? Oh, that's interesting. Where should I position the power supply components away from signal trace diagram? That's interesting. So essentially, I guess your board. My guess is that there's some kind of like, and this is a guess, okay? So if your power supply is here, right? I'm assuming the way that I assume is that this has some sort of like radius that is like a no like a no area, right? Where essentially you have to just basically minimize the trace, right? Or don't have sensitive traces. Like for example, if I have a component here and a component here, it shouldn't just do these, right? It should rather kind of like because it's going outside of the zone. That is that is a guess, okay? That is a very naive guess. I'm gonna pause the session here, guys. I'm gonna pause the session. I'm gonna stop the recording, but live streaming